All right, let's go ahead and get started. I want to welcome you to the sixth installment of Unit 0. We're going to be talking about something called rules for scientific notation. Well, first of all, what is scientific notation? Well, as it turns out, very often in science, we write numbers that are either very, very large or very, very small. Let me give you some examples. If I wanted to denote, for example, the speed of light, this is how fast light travels in space. I'll put a 3 and then this many zeros. 1, 2, 3, 4, 5, 6, 7, 8. And that's in meters per second. We'll learn later on that the speed of light is a constant. Light travels at that speed. Now, as you can see clearly, it would be very cumbersome to have to write that number again and again and again. Say, for example, if you were Albert Einstein writing a paper on general relativity. So you would need to be able to have some type of a shorthand, and there is in fact a shorthand that we can use to write that number. A concept that we'll be learning on later on in chemistry is something called the mole, and we'll learn that the mole is a large number of particles like atoms or molecules, and that number is 6.02, and then believe it or not, there's 23 zeros after that, right? So that would really get cumbersome if we had to write that. So 6.02 and then 23 zeros after that. So we're going to need a shorthand, okay? And here's how it works. The way that it works is we write a base number. So I'll write one right here, for example, 4.32. And then I multiply that number by 10 to some exponent. Let's say I'm going to say 14, right? Well, that 10 to the 14th is the equivalent of 14 zeros that is added after the 4.32. So it's a shorthand way of writing many, many, many zeros. If I wanted to write the speed of light, for example, I could write this. Instead of writing 3,000,000,000,000, I could write it like this. The speed of light is 3.0 times 10 to the 8th meters per second. Now that's obviously much easier to do. Or if I wanted to write the number 6.02 times 10 to the 23rd, or with 23 zeros, I could write it as 6.02 times 10 to the 23rd, just like that. Obviously, a lot less cumbersome than writing 6.02 and then actually physically writing out 23 zeros. So let's get a little bit of practice with scientific notation and see how we can use scientific notation to our advantage. So for a number written in scientific notation, there can be one and only one number to the left of the decimal. Only one number to the left of the decimal, remember, in scientific notation, will carry the rest of the zeros with the exponent on the 10. Small numbers have negative exponents and larger numbers have positive exponents. So if you have a small number, you're going to have a negative exponent. That's a number less than 1. If you have a number greater than 1, that's a positive exponent. So how does it work? Well, let's take this example. Say we want to express 0.00000000902 in scientific notation. Now that's a very, very small number. It's a number much, much smaller than 1. So we know we're going to have a negative exponent. So how do we do this? Well, where would the decimal go to make the number between 1 and 10? The decimal is currently here. If I had to make the number between 1 and 10, put it right here between the 9 and the 0. That would make it 9.02, right? 9.02 would put the left number between 1 and 10. I can only have one number to the left of the decimal. Now, how many times did I move the decimal to the right? Well, I moved it 1, 2, 3, 4, 5, 6, 7, 8 places to get it into that position, right? 8 places to get it into the 9.02 position. So how would I write the number in scientific notation? Remember, I moved it over to the right because it was a very small number. So I would write it as 9.02 times 10 to the negative 8. 9.02 times 10 to the negative 8. Let me write that a little bit bigger so you can see it. 9.02 times 10 to the negative 8 is a very small number, right? So that's how you do a simple one. Now let's take a look at some others. Here we go. So let's say we want to convert 0.00034 to scientific notation. That's a small number. It's not too terribly small, but it's pretty small. So where would I have to put the decimal to get it to one number to the left and no more than one number to the left of the decimal? Well, the decimal is currently here, obviously. So if I move it over here, 1, 2, 3, 4 places to the right, then I would call this number 3.4 times 10 to the negative, because I moved it to the right. Small numbers get negative exponents. Let's count one more time. 1, 2, 3, 4 places. So I say 10 to the negative 4. Okay? So 0.00034 is 3.4 times 10 to the negative 4. I'm asked, by the way, to determine correct number of significant digits, right? So how many significant digits are in this number? Well, remember, leading zeros don't count, ever, even if there's a decimal. Trailing zeros count, but there's no trailing zeros here. We only have a 3 and a 4. That's 2 significant digits, so we say 3.4 times 10 to the negative 4th, and that would do it for the first one. Let's look at the next one. We have 0.320. How would we write that in scientific notation? Well, we don't have very far to go with the decimal. We're here now. We're just going to move it right there. So we're going to move it only once to the right. Okay. Now, notice in going from 0.320, if I write 3.20 times 10 to the, notice in going from 0.320 to 3.20, I've made this number, this part of the number, 10 times bigger. So I have to compensate by making this number 10 times smaller. It becomes a negative 1. So 0.320 becomes 3.20 times 10 to the negative 1. Okay? Let me erase this to get this out of the way for our next one. Let's look at this one. We have 368,000. We want to express that in scientific notation. Well, even though there's no decimal there, the decimal is implied to be right here. It is a whole number after all. And so what we're going to do is we're going to move the decimal place over so that there's one and only one number to the right of the to the left, of the decimal. So here we go. 1, 2, 3, 4, 5. Let me do that again. 1, 2, 3, 4, 5. That's pretty close together, so it's hard to see. But that was 5. So I'll write my number as 3.68 times 10 to the 5th. Now, let me show you this. I'm going to erase this marking right here, and I want to show you something. I want to show you that that decimal was an implied decimal. I put it there to determine how many places that I had to move. Now, if there's no, remember, for trailing zeros, if there is a decimal, then those trailing zeros will count. But if there's no decimal, trailing zeros don't count. So that means I have only 3 significant digits. So I wouldn't write 3.68000 times 10 to the 5th, but rather just 3.68 times 10 to the 5th. In other words, if they don't count, if they're not significant in the original number, they're not significant in the scientific notation number. All right? And the last one is 48.687. So I'm going to move the decimal place over once to the left. That places it between the 4 and the 8, and I write it as 4.8687 times 10 to the what? Well, how many places did I move it? Once. In what direction? To the left. I made the number 10 times smaller. It was 48.687. Now it's only 4.867. So if I made the number 10 times smaller, in that case, if that's what happened, then I have to compensate it by making this part of it 10 times bigger. I'm going to make that 10 times 10 to the 1st. I realize that this is not very much practice, but we're going to be doing a lot more on a worksheet or two that's going to be coming up shortly. But I just wanted to, in these notes, show you the rudiments of how to do scientific notation. And we'll practice a lot more later. All right, that'll do it for this one. I'll see you in the next one. Thanks. Bye.